And welcome to First Step Science today. This month, we are night explorers. All month long, we're going to be doing activities and experiments about things in the night sky. And the National Park Service has put together this wonderful booklet with a lot of really neat activities that I'm taking some of our program today out of. And if you join us for more than 2 episodes of First Step Science this month, you can sign up and we can give you one of these booklets and also a patch that looks like this on the back. You get a really cool one. So I hope you become night explorers with me today. And today our episode is all about the moon and a few things about the stars. So you can have fun doing these activities along with me and get your patch. And let's get started with that, about asking questions about the moon. So here's the first question for you. Why does the moon seem to change shape when you look at it from night to night? Sometimes you see, a nice big round moon in the sky. Sometimes you see just a little sliver that looks like a fingernail in the sky. Why does it do that? Well, we call these changes in shape phases. The moon goes through phases. Why does this happen? Well, let's first do an activity together and see how the moon moves in the sky, how the moon moves around the earth. And we said to have a pie pan ready and a little bit of Play-Doh and a little ball. So that's all you'll need to do this first experiment today. Now, let's talk about orbit. That's a nice word. The moon orbits around the Earth. That means it goes around the Earth. So I have this piece of Play-Doh, and I'm going to take a little bit of it and kind of roll it in a ball and stick it right in the center of my pie pan like that. And I'm going to press it down. Press, press, press. So it's going to stick. So there is the Earth. Everybody see that? There's the Earth in the middle of my pie pan. And so now I have a ball that I'm going to call the moon, and I'm going to put it around the edge, and then I'm going to see if I can get the moon to orbit the Earth. There we go. See how the moon goes around the Earth? Whoops! Uh-oh. Every once in a while I lose balls in my den, but not this time I found it. So there we go. The moon is orbiting or going around the Earth. And in real life up there in the sky, it takes 28 days for the moon to go all the way around the Earth and back again to the start. And so that's the cause of the phases, but that's not the only reason. The sun, let's use my flashlight as the sun, oops, hold on, the sun shines in the sky, and so we here on Earth see different parts of the moon lit up by the sun as it goes around in the sky around the Earth. So let me hold up my ball here and maybe you can see that a little bit differently. So there's the sun, and the light from the sun is falling on a portion of my little ball, and as the moon goes around the Earth, different parts of it get lit up. So that is why we see different phases. Now you can actually do this experiment outside on a sunny day and hold your ball on the end of a pencil, put the sun behind you, and then turn all around. And you can watch different sections of your ball get lit up in the different shapes of the moon phases that we see. So let's do this activity to kind of illustrate the phases of the moon with Oreo cookies. That's my favorite. Anytime we do an experiment with food, I love it because you can eat it. So what I'm going to do is change my camera view to the tabletop view so that you can see what I'm doing. on the, whoops, on the table. And let's make some moon phases together. Okay, so to do this, you need, I've got about 9 or 10 Oreo cookies. We may not use them all. Oops. And I've got a plastic knife. And I've got, you may just have a piece of paper, or you could just use your tabletop. And we're going to place the different phases around the Earth. So I have kind of a cheat sheet here that I printed out to keep me on track. And so here's my sun again. So my sun is going to be over, okay, turn it on. My sun is going to be over here. And there we go. Yep, whoops, no, wait, my sun is going to be over here, so we can see which part of the Oreo cookie, our Oreo cookie moon, will light up so we can see it here on Earth. I'm going to turn that off for a minute. So let's get started with the cookies. There's a lot of different phases. One of the phases of the moon is when you can't see it at all, and that's called the new moon. So I'm going to take my Oreo cookie here, and I pulled it apart, so I have two halves, and I'm going to scrape all of the frosting off of one so it's black. And actually I could use this side of the Oreo, and I'm going to place that down right here. And I'm going to use this little ball as my Earth. Whoops, stay. I might have to tape that down. My Earth ball is rolling around. You might have another way to do it. Okay, there we go. Stay, Earth ball. Okay, so there is the phase called the new moon. And let's see what that looks like when I shine the sun. Okay, so there's the Earth, there's the sun, there's the moon. The moon is right in between the sun and the Earth. And so the light from the sun is blocked and you can't see it. We can't see it in the sky. So it's a new moon. We can't see it at all. All right, so another phase that the moon has on the opposite side, when that moon orbits the Earth, on the very opposite side is the full moon. There's your other half of the Oreo cookie. And that is when the sun is going to light up the whole face of the moon for us, just like that. So it's always on the opposite side of when the moon is new. It's on this side, in between the sun and the Earth, and then the Earth is in between the other. Okay, so, and there's a lot in between. Look, I have 1, 2, 3, 4, 5, 6 more. So now, if we start with the new moon, and we're trying to get to the full moon, that image that we see in the sky is going to have to get bigger. And we call it waxing. And it starts out really little at first. So I'm going to break another Oreo cookie, and I'm going to take this surface, and I'm going to take my knife, and I'm going to scrape off some frosting so it looks like a crescent, but a crescent that's getting bigger. But right now it's going to be little, so I'm going to try to do a crescent, without killing my Oreo cookie. Oops, there we go. So I hope you're having fun with this. Taking some frosting off so the frosting looks like a crescent in the sky. Whoa. It's like defrosting cookies, right? Okay, so there we go. So there is our waxing crescent, and the part that we see lit up by the sun is just a small amount, and it's a crescent. There, can you see that? Here's my sunshine. Oops. There's my sunshine, and there we go. Okay. Now, have you seen the moon in the sky when it's kind of like half a moon. Well, the moon went from a crescent, it's going around the Earth, to over on the side there. I'm breaking another Oreo cookie. Uh-oh, I broke the whole cookie. Whoops, that's not good. We'll try that again. Here we go. I'm breaking my cookie, and we're gonna make a half a moon, and we call this the first quarter. So I'm taking some of the frosting off, and it's gonna look like a half. And it's getting bigger. So that's the first quarter. There we go. We got one more, and we call it a waxing. It's getting bigger. Small crescent, half a moon. Now we're doing a waxing gibbous. That's the next phase. So I'm breaking my Oreo cookie in half. And this time I'm going to have more frosting. And I'm just going to do this. Whoops, more frosting, more frosting. And it's more than half. Oops. And I hope you're having fun. You know, you can lick the frosting that you scrape off your Oreo cookie. That's my favorite part. And that's our waxing gibbous. There we go. And of course, the sun is definitely over here shining again. All right, so now we've got the full moon. We did that. It's on the opposite side of the new moon. And when the moon is going to start to get smaller again, and that's called waning. It's getting smaller. So after the full moon, we have a waning gibbous. This was the waxing gibbous, getting bigger. This is the waning gibbous, getting smaller. So I'm breaking my Oreo cookie in half. And I am going to scrape off a little bit of frosting, but not a whole lot, because there's still a lot of that moon. And every night, if you watch the moon every night, a little bit more will either disappear or reappear, depending on what phase that moon is. So this one is a waning gibbous, and it's starting to get smaller again. There we go. I'm running out of space here. I need to make my circle bigger. Okay, and then we get back to the opposite one. Remember, that was the first quarter. Here's the other second quarter. Oh, I broke it again. Oh, wait, I can fix this. Okay. All right. So this one is going to be the third quarter. Uh-oh. I need some more frosting. And I'm going to... Oh, that really broke. Ah! I guess I need a whole new cookie. That one wasn't good. All right, so here we go. This one will work. I got a whole one now that I am going to cut off half of the frosting. And it will look like, well, almost half of the frosting. Ah! This is harder than I thought. I can't wait to eat this frosting, though. Okay, there's the half. Well, sort of. Almost. There we go. All right, and one last one before it disappears back to a new moon. A crescent. And I have one. This one better work because I'm out of Oreo cookies. I ate a bunch last night for a snack. So I'm gonna scrape it till it's just a little crescent, because the moon is starting to disappear in the sky. It's really not disappearing, it's still there. It's just the part that we see is only where the sunlight hits it, and it's just a small crescent by the time it gets all the way over to the waning crescent. So there we have it. I'm gonna light up the sun one more time. Whoops, the other way. There we go. There's the sun, there's the earth, and the different phases of the moon that we can see as the moon travels around our earth. 28 days. There we go. Okay, so that's a little bit on why we see the reflection of our moon and the phases. And that brings us, I'm going to get this out of the way. take my Oreo cookies and move them out of the way. And I'm going to change the camera again because we're going to do something face to face here because I got another question for you. Okay. All right. My next question is, how does the moon shine? We say that the moon shines, and we were just talking about our Oreo cookie phase model and seeing the part that we could see, and the moon shines big and bright or small like a crescent. How does the moon shine? Well, we say the sun shines, and you know the sun is a great big old fireball, and it's actually a star. But what's the moon like? How do we see that moon's light? Is it really coming from the moon? The moon actually is made out of rock. And I've got a big old light colored rock here that I found outside. And when I shine some sunlight on it, ooh, it makes it look even brighter. Well, I said a word a little bit ago. I said reflection. And that's what it is. The sun's light travels from the sun, hits the moon, and is reflected off the moon's surface, just like it's reflected off this rock. See how bright it got when I put the flashlight on it? Yeah, it's reflecting the sun's light. It doesn't actually burn like a fireball like the sun does. It reflects the light. So let's do an activity to talk about reflection and how the moon reflects the light. For this activity, you're going to need a paper towel tube and some aluminum foil. And I got a small flashlight too, but I might use my big flashlight. So this one's an easy one. I've got something shiny, like my Reynolds aluminum rack, and I'm going to pull off a little bit here. See how that's shining back at you on the screen? And I'm going to wrap that shiny edge right around the edge of my tube, just like this. Okay. And it'll stay there. You don't even need a rubber band or anything to make it stay. You can just squish it. Okay. And then I'm looking down the tube and I can't see it. I blocked the light. But if I add the sun's light, shine it down my tube, it'll actually reflect so I can see that shiny surface. So let's try it with the little flashlight first, because you might have a little flashlight. And kind of look down the tube, hold it at your arm's length, look down the tube, and then raise your flashlight. Can you see the shine reflecting off the aluminum foil back to your eyes? I can. Okay. So hold that flashlight up until you see the reflection. Now let me turn that towards the camera and see if you can actually see it. I don't know. Maybe. Oh, yeah, maybe. It might be too small. Let me do the big flashlight. But you can certainly do this at your house. And I'm turning on my big flashlight. And I'm holding my tube at arm's length, and I'm shining my sunlight down the tube, and I'm lighting up the disc at the end, and it's bright. And that's how we see the moonlight. It's actually sunlight reflected off the moon. I think that's kind of cool, kind of neat. So I hope you had some good luck doing that. It's a nice, easy experiment to talk about reflection. Whoops, there we go. All right. Okay. Reflection tube. So we've been talking about the moon for quite a bit here. So let's start to talk about the stars. Well, I notice when I go out at night that the stars kind of move in the sky from time to time. What's that all about? Well, remember our orbit? Well, not only does the moon orbit, around the Earth, but the Earth orbits around the sun. And it takes us 365 days to orbit around the sun. So just like our pie pan there, we're going around the sun And that kind of changes the view of our sky a little bit from night to night and from season to season. So what I have here is my big globe, my big Earth. Ooh, it's squeaking. There we go. And so not only do we turn from night to day, here's my sun. The daytime part is lit up by my sun, but we also go around the sun and it takes a whole year. So there's lots of motion there going on when you look up in the sky. So I like to, whenever I go out, I like to see the Big Dipper. So when it's clear, I always look for the Big Dipper. And that's one of the constellations that I always see and always notice. And I notice that sometimes it's standing on its handles, sometimes its dipper shape is just sitting there just looking like a dipper and holding a handle so it would actually hold some water or something. So what is that all about? Why does that change? Well, take a look at my globe here. There we are. If you can see a couple of things on it. There's the equator, there's the North Pole, and we are sort of tilted. If you took a stick and stuck it all the way through the North Pole to the South Pole, you'll notice that it's sort of on an angle. And our North Pole is actually pointed to the north, and we see the star Polaris. It's pointed right at the north. And then a lot of the stars that our view of the sky seem to go around that star called Polaris. So I've got this little guy here, and I'm going to stick him right on Michigan, looking towards the north. There he is. He's stuck on there. And there's his view of the sky over there. So why does... Okay, so there we go. Ah! I can't get him past our thing, but look how his view of the sky would change. Down over here, back around there. Of course, it would go around here, right? And I'll stick him back. I had to get around the bracket. There he is. So let's build a view of the sky, just a model. And for this, I've got a big, huge, black umbrella. Can you see my big, huge black umbrella? I hope you can. We're going to take a look underneath that umbrella and pretend that that's this little guy's view of the sky. And it can be yours. So now let's get our globe out of the way. So if we hold this umbrella and we decide that the very center of this umbrella is Polaris, pointing north, we can put some star constellations on here and then turn it and watch and see how the position, and we're going to look at the Big Dipper, how it changes, how our view of the sky changes. So here we go. I'm going to put my globe down and work on this umbrella. Now, if you have some chalk, you can use chalk, but I don't happen to have any chalk right now. I have some little white stickers. So remember that the very center of my umbrella is Polaris. And I'm going to draw with stickers a Big Dipper on my umbrella. So, and you could put some dots on your umbrella with chalk if you have it. If you have Sidewalk chalk or any other kind of chalk, you can do that. So I am going to put some stickers on my umbrella where the stars in the Big Dipper would be. There, I'm going to build the handle first. Okay, whoop, sticking it on there. It won't come off. All right, so there's maybe some stars on the handle of the Big Dipper, and the Big Dipper's bowl. And you can do this with chalk if you like. Oops, I'm not doing a very good job of drawing a Big Dipper with my stickers. But there we go, we'll try that. Here's one. There you go. Oh, I dropped it on the floor. We lost part of the dipper. There we go. There it is, the Big Dipper. Can you see that? Okay, so I can also draw another constellation that I see when I go out all the time, and that is Cassiopeia, and it looks like a W. So I'm going to do a W over here with my stickers, sort of a lazy W. And you can do this with chalk. You could just draw a W with dots. There you go. Okay, way over there. And I could do a lot more, but I don't need to right now. So now I'm going to pretend that I am looking straight north, right at Polaris. And then I'm going to turn my umbrella around and look at what I see when I look at the Big Dipper. Can you see that? Okay. Now it's standing on its handle, and now it's coming down in the sky. And you can see how its shape, or how its position changes over the seasons and over the night. There we go. All right, so that's kind of a fun thing to try. I'm going to get my umbrella here out of the way and set it down. So, hope you get a chance to go out and look at the stars in the sky. And if you do, I think one of the things that you're going to notice is some of the stars are brighter than others. And this is our last activity for today. And I'm going to turn on my tabletop camera again so you can see what we're doing. There we go. Okay, so to do this activity, I've got just a chunk of poster board, and I've got some cellophane. And the lighter, if you have yellow cellophane, that would work even better than my red here. But today I only have red, so that's the way it goes. So we're going to make a star brightness detector. And the first thing I'm going to do with this is to cut some holes in my piece of poster board. You could do with this with cereal box cardboard or any kind of cardboard. And I'm going to cut a rectangle. So I'm sort of folding this in half, and I'm going to make 4 rectangles. Fold it in half, and I'm cutting. Let's see what it turned out like. Here we go. There. So that's kind of like, I can look through that. I can look through that rectangle. So I'm going to do 3 more. About the same size. This is a star brightness detector. 1. So when you go out and you can see a lot of bright stars, you can kind of measure how bright they really are by doing this. Okay, now I have 4 rectangles. Now what am I going to do with my cellophane? Well, I need some tape. So if you have some tape, we're going to get that out now. And first, I have a pretty big piece of cellophane that I'm going to put all over the rectangles that I cut. And I'm going to tape it down. So now I have a single layer of cellophane. Like I said, probably yellow would be the better choice, but today I only have red, and I'm going to test it out the next time that the stars come out to see if I can actually use red cellophane or not. Anyway, so I'm taping that down. So I have a single layer of cellophane over all of my rectangle viewing spots. Okay, so now I have another piece of cellophane that I'm going to use to cover up the next 3. See, there's one with only single. Now I moved another wider piece down over 3 of the rectangle holes. Uh-oh. There we go, and I'm taping that on. This one's a little wide. Oops. Okay, there we go. Okay, so this has a single layer of cellophane. This has a double, and that has a double. So now I got another piece of cellophane, and I'm going to cover up two of my viewing rectangles. So now I have single layer, double layer, triple layer of cellophane. And you can probably guess what I'm going to do with the last one. Oops, there we go. Oh, that didn't catch, just a minute. Okay, there, I'm taping that down. All right, so single layer, double layer, triple layer, and then I have one more hole, and that's going to be a quadruple layer. That's a big word for 4. And taping that down. So when I take a look at this, every time I've added a layer of cellophane, it blocks out a little more light. Okay, so back to our FaceTime camera, and let's see how to use this. Okay, so there it is. We built it. Single layer, double layer, triple layer, quadruple layer. Each one blocking out a little bit more light. So when you go out and look at the stars, find a great big bright star to look out. It's this time of year, maybe a couple of the ones in Orion will be shining brightly if the clouds ever clear. And hold it up to your face and look through the top. Can you still see the stars that you spotted without it? Then try looking at that same star with a double layer. And then a triple layer. Whoa, each one blocks out a little bit more light. So you can see, and see if you can find any stars with that quadruple layer. And you can make your own records. You could call this layer a star brightness 1, star brightness 2, star brightness 3, star brightness 4. It's kind of fun to try. And in real life, scientists measure the magnitude or the brightness of the stars. 1 is the brightest, and I think it goes up to about 6 or 10. I can't remember which, but those are the dimmest. The higher the number, the dimmer the star. Same with your brightness detector here. Or if you don't have any cellophane at home, you can still do this kind of thing by a simple pair of sunglasses. I wear my sunglasses at night. You heard that song before? So you can wear your sunglasses at night. First find a really bright star in the sky, and then see if you can still see it by putting on a pair of sunglasses. And check out a whole bunch of different stars and find the ones that you can still see with your sunglasses on. So that is really exciting and fun to do. So that's all we have for First Step Science today. And we hope that you had fun thinking about the moon and questions about the moons and the stars. And join us again next time. Bye for now. Something I had never ever seen before. And here's where you get to make a choice. Was it a giant Tyrannosaurus Rex? And I'm just gonna stick some pie cones in my box, and then the fun starts. I just start rolling them around. Air rushing out of the balloon is going to push that balloon up. So let's see what happens. All right, 1, 2, 3. Oh, wow. So that's how rockets kind of work. We are going to build 2 different kinds of rockets today. Put the cork on as fast as you can, set it down, and wait.